Section 14C, Question 2, page 353. The question asks us to use technique found in Investigation 3 in the textbook in order to find the gradient, the gradient of the tangent of the function y equals x squared at the point 2, 4. So I've set up some points here. So the target point is 2, 4, and I'm going to look at the curve y equals x squared, and the curve looks, I'm just going to do a very rough sketch here. I should be using a ruler, I know that, but the curve is something along this line, and point 24 would be somewhere around here. I know this is not accurate at all. And then what I'm going to do is I'm going to start moving in from the right. So I'm going to start at point 416, which would be around here-ish. And then if I were to draw a chord between those two, join those 2 points, draw a chord, then I would then use the gradient formula of y2 minus y1 over x2 minus x1 to find the gradient of that chord between these 2 points, and I would find that that gradient is 6, because I'm doing 16 minus 6 divided by 4 minus 2. Then as I move this point closer to 3, 9, and there's a chord between those 2 points, this point B has now moved down the curve closer to point 24. It's now at point 39, and I find the gradient again by doing 9 minus 4 divided by 3 minus 2, which gives me a gradient of 5. Then I move this point even closer down to x equals 2.5, and when x equals 2.5 and I substitute that into y equals x squared, I get the y value of 6.25. And then again I find the gradient, 6.25 minus 4 divided by 2.5 minus 2, and that gives me a gradient of 4.5. And I continue in this manner, move this point even closer to 2.1, the x value of 2.1, which is very close to 2, and the y value is then 4.41, and then I subtract and divide and get a gradient of 4.1. I move this point even closer to an x value of 2.01, which is even closer to 2, and when I square that in y equals x squared, I get the point 4.0401, and then again 4.0401 minus 4 divided by 2.01 over minus 2 gives me a gradient of 4.01. And I do that one more time, move this point even closer still to 2.001, the x value, and then the y value of that point is 4.004001, and then I subtract again and divide to get the gradient, and I get the gradient of 4.001. So we see that as this point 4 moves closer and closer down the curve, closer and closer towards that point 2, 4, we see that the steepness of the chord is getting less and less, and it seems to be leveling off at some certain value, but we'll be able to tell that a little bit better when we move from the left. We'll do the same thing. Now moving from the left, I'm going to start at this point here at 0, 0, the origin, and when I find the gradient of that chord between this point, the origin 0, 0, and this point at 2, 4, that chord, the gradient there is going to be 2. When I move this point up to x equals 1, the y coordinate is going to be 1, because I substitute this x into y equals x squared to get 1, and then I do 4 minus 1 divided by 2 minus 1, and that gives me a gradient of 3. So the gradient is now steeper than here. Then I move up even further, up to the x value of 1.5, and when I square that I get a y coordinate of 2.25, and then I subtract and divide again in the gradient formula to get a gradient of 3.5. I move this point even closer to x equals 2, I move it to 1.9, and when I square 1.9 I get the value of the y-coordinate of 3.61. Then I put it into the gradient formula and I get 3.9. I move the point even closer to 1.99, which gives me a y-coordinate of 3.9601, and that gives me a gradient of 3.99, and I move it even closer still to x equals 1.999, which gives me a y-coordinate of 3.996001, and that gives me a gradient of 3.999. So we see that as I move from the right closer to the point 2, 4, the gradient is getting less and less steep from 6 going down to around 4, and when I start from the origin and move up to from the left up towards that point of 2, 4, we see that the gradient is getting steeper and steeper up towards that value of 4. So we can say then that the estimate of the gradient of the tangent at 2, 4 would be approximately 4. Question 2b asks us to evaluate this limit, the limit of x squared minus 4 divided by x minus 2 as x approaches 2. So I'm just going to simplify this a little bit so I see that x squared minus 4 is the difference of squares. I can factor that to x minus 2 and x plus 2 all over x minus 2. I see I have a common factor of x minus 2, which I can then simplify down. So then now I'm finding the limit of x plus 2 as x approaches 2, and then now I can just do simple substitution, which gives me 2 plus 2, which gives me 4. So that tells me that as x tends to 2, the gradient of f of x at x equals 2 tends to 4.